Hi guys, okay, we are doing January 2019 paper 2. Here is the formula sheet and here is question 1. So we have a plane, it has a length of 73 meters and we have a scale model that is at this scale 1 to 200. And the real plane is 7300, so we need to find out let's call this x. x2 or 1 to 200 is the same as something to 7300, because careful guys, it says give your answer in centimeters. So 1 meter is 100 centimeters, so 73 meters is 7300 centimeters. So 1 to this is the same as what to 7300. Well, if I just divide this by 200, I will get I'll get x. So I need to do 7300 divided by 200. There, I've already done it. It's 36.5. So we have 36.5. That's question 1. Question 2. There are 5 terms of an arithmetic sequence. 1, 2, 3, 4, 5. Write down an expression in terms of n for the nth term of the sequence. Right. The quick way to do it, guys, the very quick way is you go, okay, it's going up in 4s, plus 4, plus 4, plus 4, plus 4. And then I say, okay, so the nth term has to be 4n, because it's going up in 4s, plus what do I need to add to get to 7 if n was 1? So just pick one of these. If n was 1, I have 4 plus something, which is 3. So the answer is 4n plus 3. Easy. However, I like to use, guys, this formula, a plus n minus 1d, because this formula can be useful in different, if the question's a bit harder, sometimes that's not always easy to figure out. So this formula is not given in the formula sheet, so you need to know it. A plus n minus 1d. A is 7. N is just n, because I'm trying to find the nth term, and d is 4. So I just multiply this out. 4 times n is 4n. 4 times negative 1 is minus 4. And I'm left with 4n. 7 minus 4 is 3. 4n plus 3, which is obviously the same answer. Okay, question 3. There are 90 counters in a bag. Each counter is either red or blue, so that the number of red counters to blue counters is 2 to 13. Okay, red to blue is 2 to 13. Now guys, this question for a question 3 is actually not that easy. I know it's not easy because I don't think I know how to do it yet, so let's figure it out. Lee's going to put some more red counters in the bag so that the probability of taking a random counter is 1 over 3. Work out the work out the number of red counters she needs to put in the bag. Okay, so firstly I'm going to do my 2 plus 13 is 15. Add these two, so make it into 15ths. I'll do 90 divided by 15 gives me 6. So now I know that in the bag there are 6 times 2, 12 red counters, and 6 times 13, which is 78 blue. So this is how many are in the bag. There's 12 red, 78 blue. Now she's going to add in some more counters. She's going to add in red counters. So the red counters she's going to add in is some unknown. So let's call it x. She's going to add in x, 12 plus x to 78. So now we're adding in, okay, let's be clear here. We're going to add in x amount of red counters, and this has to equal 1 to 2. So okay, be very careful here, guys. We actually, hang on, I'll do it a different way. Well, I am going to say there's 12. There is 12 plus x red counters. Okay, let's do it this way, it's easier. So we have added in x counters, some unknown, so we're trying to find x. So this out of the total, so how many, once I've added in x, what's the total of counters in the bag? Well, it's 90 plus x, because I've added in x, there was 90, and I've added in some unknown. So this has to equal, this over this has to equal 1 over 3. Okay, so that's the key to the whole question. If you understand this, you're good to go, because you can just solve this. So multiply across, I'm going to say 3 times this equals 1 times this. Multiply out, 36 plus 3x equals 90 plus x. 3x minus x, subtract the x, equals 90 minus 36, subtract the 36. 3x minus x is 2x. 90 minus 36 is 54. And then x equals 27. So that's the answer. So this, guys, that was for, as I said, for question 3. That was hard. Question 4. Okay, so the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A is the odd numbers. A intersection B is 1 and 3, and A union B is this 1, 2, 3, 4, 5, 6, 7. This is a bit sneaky, guys. That's why you gotta count them. There's no 8 and there's no 10. I'm actually gonna write that in here. No 8 and no 10. Just so we're clear. Draw a Venn diagram. Right, so I'm gonna draw a circle. That's a nice circle. And I'm gonna draw another circle. That's a nice circle. I'm gonna put that here, make that a bit bigger. Okay, this is A, and this is B. Now he says 1 and 3 are in the intersection A intersection B, which means 1 goes there and 3 goes there. A union B is 1, 2, 3, 4, 5, 6, 7, 8, 11, and 12. Okay, that means this 8 and 10, they don't go anywhere. So they go here, 8 and 10. Somewhere not in A and B, but they are in the universal set here. A is then the odd numbers. So we have 1 and 3. We then have to put in a 5. We have to put in a 7. We have to put in a 9. And we have to put in an 11, because these are all the odd numbers. 1, 3, 5, 7, 9, 11. 1 and 3 are also in B. So what's left has to go in B. So we've our 2, we've our 4, we've our 6. We don't have our 8, we don't have our 10, and we have our 12. And that's it. Done. That is 4 marks. That's a nice 4 marks, guys, in my opinion. Question 5. Calvin has 12 identical rectangular tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. He arranges the tiles to fit exactly on the edge of a shaded rectangle as shown. Work out the area of the shaded rectangle. Okay, this, guys, I think is manageable. Okay, so, well, actually, it looks kind of hard. This length here is 123, the total length, and this length is 67. So the total area equals 1, 2, 3 times 67. 1, 2, 3 times 67. 1, 2, 3 times 67 gives me 8, 2, 4, 1. 8, 2, 4, 1. But to find the length of these rectangles, the smaller ones, I need to look at what's going on here. Okay, so what I'm gonna do actually, guys, is, right, this is harder than I thought. Let's see how many marks. Okay, it's 5 marks, which makes sense because it is tricky. I am going to call the length of one of the rectangles x, so that's x, and I'm going to call the width y. So That means I'm going to actually create two equations here. So the length, this length here is x. Well, it's 1, 2, 3, 4. There's 4 x's. X plus x plus x plus x and a y. So this length here is 4x plus y, and it equals 123. 1, 2, 3. So that's my first equation. 4x plus y equals 123. The next equation is I have 2 x's plus, let's say, a y here. X, x, y. This has to equal 67. So I'm going to say 2x plus y equals 67. Now I have, well, I've created two equations, and I have to solve them simultaneously. So this is simultaneous equations. That's why it's hard, because I thought it was just area of a rectangle, but of course they've made it difficult by making it simultaneous equations. So how do I solve simultaneous equations? Well, I make these the same, and the y's are the same, which is nice. So I just have to subtract. So I'll subtract this minus this. So it's this minus this is 2x. This minus this is 0. This minus this is 56. Is that right? 56. Yes. So that means x is 28. I divide by 2. Now once I have x, I can get y. 2x plus y equals 67. That's this equation here. 2x plus y equals 67. X is 28. So 2 times 28 I know is 56. 56 plus y equals 67. Y is equal to 11. Okay, so now I have x and I have y. Area of small rectangle is equal to x times y, which is 28 times 11, which is 28 times 11. 308. 308. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 of them. So 12 times 308 is equal to, I'll just do times 12, 3696. 3696. So that's the area of all of these. So I just need to do total minus this. So shaded area shaded equals the total, which is 8241, minus all the tiles, which is 3696, and I get 8241 minus 3696, 4545 centimeters squared. 4545. I'll put that here. Okay. Question 6a. Find the highest common factor of 96 and 120. So, guys, you could probably maybe figure this out on your head. I'm going to do it like this. 96 equals fact. This gives me the factors, the prime factors. It's 2 to the 5 times 3. 120 is equal to 120 equals fact 2 cubed times 3 times 5. 2 cubed times 3 times 5. And then I always like to draw my Venn diagram. So I draw my Venn diagram. This is for 96. This is for 120. What is common? Well, there's a 3 that's in both. And then there's a 2 cubed here and a 2 to the 5 here, which means the common is the 2 cubed. I only need the intersection, guys, so I don't even have to bother doing the rest of it. So the highest common factor is 2 cubed times 3, 2 cubed times 3, which is 8 times 3 is 24. So obviously write down the answer, which is 24. Okay, find the lowest common multiple of these. Okay, guys, I'm gonna again draw a Venn diagram, this time with 3. Okay, that will do. So this is A, this is B, and this is C. A is 2 cubed times 5 times 7 squared times 11. So basically, guys, what we need to fill in what goes in the middle. Well, what goes in the middle is the thing that's in all of these. There's actually none. There's no number that's in, there's no 3 here. There's no 3 here. There's no 3 here. And there's no 7 or 11 here. So nothing's going to go in there. Between A and B, I have a 2 cubed, because there's a 2 cubed in both of them. And I have a 7, because there's a 7 here in B. And I have an 11. Which means what's left for A, well actually, sorry, let's do the intersections first. So that's A and B. Then let's do A and C. So I have a 5 that's in A and a 5 that's in C. So I'll put a 5 there. And what's between B and C? Well, they actually have no common numbers between B and C. So now I just need to do what's left. So I have my 2 cubed in A, I have my 2 cubed, I have my 5. I have one 7 here, so I need to put another 7 here, and my 11 is there. So that's fine. What's in my B? Well, I have 2 to the 4 there, and I've only 2 cubed there, so I need to put another 2 there. My 7 is there, and my 11 is there. That's fine. And finally, C has a 5 there, but we need a 5 squared, so I need another 5, and a 3, which is going to go there. So my lowest common multiple is all of this multiplied together. So I'm going to do 7 times 2 cubed times 11 times 7 times 2 times 5 times 5 times 3. All of that, which equals, okay, let's do it. 7 times 2 cubed times 11 times 7 times 2 times 5 times 5 times 3, which is 646,800. So obviously it's a big number, 646,800, but you'd kind of expect that because these, I mean, A on its own is a super big number. So there you go. Okay. Question 7. Jenny invests $8,500 for 3 years in a savings account. She has 2.3% per year compound interest. How much money will she have in her savings account at the end of 3 years? Give your answer to the nearest dollar. Right, there's a formula for this, guys. This is a nice, easy question for 3 marks. It's 8,500 times 1 plus the interest rate. So it's 1.023. That's the multiplier. The interest rate is 2.3%, so I need to do 1.023. If I did 1.23, that would be 23%, so be careful. And then it has to be to the power of 3, because it's 3 years. And this gives me, as I said, guys, once you know how to do that, it's easy. 1.023 to the power of 3, 9,100.09, 9,100.09. but it says nearest dollar. So here I'm going to put 9,100. Okay, next one. Rami bought a house on the 1st of January 2015. In 2015, the house increased in value by 15%. In 2016, the house decreased in value by 8%. On the 1st of January 2017, the value of the house was this. What was the value of the house in 2015? Okay, easiest thing to do, guys, call the value of the house X. So it was X. That's what its value was. And then it increased by 15%. So I'm going to multiply it by 1.15. 0.15 would be 1.5%. So 15%, I multiply by 1.15. Then it decreased by 8%. So now I'm going to multiply it by 1 minus 8%, which is 0.92. 1 minus 0.08 is 0.92. So that's how we decrease something, a quick way. So x times this equals this 687,700. X is equal to just this divided by both of these. Or I can multiply these out together first if you want, guys. So I'll do that. 1.15 times 0.92 gives me 1.058. So let's write this down. 1.058x equals this, 687,700. X is equal to 687,700 divided by 1.058, which gives me 687,700 divided by 1.058, 650,000. $650,000. $650,000. Okay, so that's, guys, look, that one's obviously not easy, but once you understand the multipliers, that's to increase, that's to decrease, then it's actually not too bad. Question 8. A block of wood has a mass of this. The wood has a density of this. Work out the volume and giving your answer correct to 3 significant figures. Right, guys? So density is equal to mass over volume. That formula is not given in the formula sheet. And look, here's a perfect example where you have to know it. Sometimes they give you the formula, but here they've not. So you need to know this. And if you understand what it means, like density, it's how dense something is. I often give the example of like gold. It's a heavy mass per volume. So if you've got even if you've got a small volume of gold, it's quite heavy. So it's dense. Whereas something like, well, let me think, a piece of wood, or let's say, well, even air is not dense at all because its mass is very little. Even if you had a big volume of air, its mass is very small. Anyway, the density we are given, it's 0.65. The mass we are given is 3.5. The thing we are not given is volume. Now it's the more difficult one to find because it's underneath the line, but we can solve this by multiplying across by v. That removes our denominator. And then to get v on its own, we divide by 0.65. So it's 3.5 divided by 0.65, and this equals 3.5 divided by 0.65, 70 over 13, which is 5.38. So 5.38, that's to 3 significant figures. Like he said, 3 significant figures, guys. First one, second one, third one, rounded here. 4 is less than 5, so I just stopped there. So it's 5.38. Change a speed of 630 kilometers per hour to speed in meters per second. Right, the way to do this, guys, is we go first change kilometers to meters. So 630 kilometers is 630,000 meters. So it's 630,000 meters per hour. So that's how fast he's going. 630 kilometers per hour, 630,000 meters per hour. But I want to find out how much he's going in seconds. So I'm going to turn this 630,000 meters per how many seconds in an hour? Well, there's 60 minutes in an hour and there's 60 seconds in a minute. So there is 3,600 seconds in an hour. That's useful to just remember, guys. 3,600. So it's 630,000 meters per 3,600 seconds. But I want to know how fast he can go per second. So if he can go this far in 3,600 seconds, I need to do 630,000 divided by 3,600 to find out how many meters he could go in 1 second. 630,000 divided by 3,600 gives me 175. So it's equal to 175 meters per second. Okay, question 9. Solve the simultaneous equation. So we've already actually done one of these, but let's do another one. So I have 4x plus 5y equals 4. I need to get either the x is the same or the y is the same. So I can either multiply this by 2 and get the x is the same, or multiply this by 5 and get the y is the same. I think it's easier to multiply it by 2. So this times 2 gives me 4x minus 2y equals 18. I multiply everything by 2. Then I need to subtract, because these are the same, so 4x minus 4x is 0. 5y minus 2y. So be careful, I'm subtracting 2y. It gives me 7y, because it's plus, minus, minus, plus. And 4 minus 18 is minus 14. Divide by 7, and I get negative 2. Then I'm going to sub y equals negative 2 into this equation. 2x minus y equals 9. I could sub it into this one too, but these numbers are a bit smaller, so it should be, well, they're both probably as easy. So I'm going to sub it into the second one. 2x minus negative 2. Be very careful. It's minus equals 9. 2x plus 2 equals 9. 2x equals 7. 9 minus 2 is 7. And then x is equal to 7 over 2, or 3.5. So x is equal to 3.5 and y is equal to negative 2. Those questions, guys, are not easy. However, it's the type of question that you have seen many times, so everyone should be able to do that in the final exam. Question 10. Find an equation for L. This is a straight line L. Okay, so the way to do this, guys, I think, is just hopefully understand gradient and then understand the y-intercept, and we're just going to write it in the form y equals mx plus c. M is the gradient. What is the gradient? So pick a point where it crosses, well, like here and here, so it actually crosses the point, and go along and go up. Now if we remember, the gradient is rise over run. What's the rise? 1, 2, 3. 3 boxes. What's the run? 1, 2. 2 boxes. Now just be careful with the scale. It is the x scale and the y scale are the same, and it is 1, 2, 3, 4. 1, 2, 3, 4. So So it's fine, but just be careful if the scale is ever different. You gotta look at the scale. So this is 3 over 2. So m is 3 over 2. And then c is just the y-intercept, which is here. So c is equal to 1. So once I have this, I can just write down the equation y is equal to 3 over 2x plus 1. And you got full marks for that. This counts, guys, as you're working. Definitely get 3 marks. Okay, question 11. 20 students took a science test and a maths test. Both tests were marked out of 50. The table gives information about the results. Use this information to compare the science test results with the math test results. Okay, so what they want here, guys, is that there's 2 main things that you have to write. That the science results were better, that you need to compare the medians. Science results were better because their median was higher. So they're kind of, one of their averages was higher. So you could argue that science results were better. And then 2, we need to talk about the interquartile range. The maths results were more consistent. So we have to bring that in, right? More consistent, or there was less variance is another technical word, but let's just say more consistent. Math results were more consistent, or less spread out. Maybe that might be a better way to put it. Were less spread out because their interquartile range was lower. There we go. That, guys, is definitely enough. Don't just write science median was higher, science interquartile range was higher. You won't get maybe any marks. I think you might get 1 mark for that, but you gotta say it in context. Like, what does that mean? This means that they were better results on average. This means they were more consistent. The math results were more consistent on average, or less spread out. Okay, question 12. Simplify n to the 0. Guys, anything to the power of 0 is 1. Yes, we should know that. Simplify this. So we have to cube everything. So 3 cubed is 27. 3 times 3 times 3. X squared cubed is x to the 6. Multiply the powers. And y to the 5 cubed is y to the 10. So the final answer is 27. X to the 6, y to the 10. Done. Part C. Factorize fully, right? So common mistake here, guys, is to go, right, this is equal to 2e squared minus 9. But this is equal to 2. So guys, this is a rule that my students always forget. If I have a squared minus b squared, this is equal to, the factors of this are a plus b times a minus b. Multiply it out and you'll see. You get a squared minus ab plus ab minus b squared. And the ab's cancel. So you're left with this. So these are the factors. So this guy is actually equal to e squared minus 3 squared, because 9 is 3 squared. So e squared minus 3 squared using this rule is e plus 3 times e minus 3. So here I can write 2 times, the 2 is just there, e plus 3 times e minus 3. And then put that there, fine. Okay, part D. Make or the subject of the formula, right? So I need to get rid of all these things, guys, that I don't like. First thing to get rid of is the big square root. So I'm going to square both sides. 6a plus r over 5r. Second thing, I don't like this denominator. Multiply across. 5r times m squared equals 6a plus r. That's multiplying across by 5r. Then get my r's on the left. So I have 5rm squared minus r equals 6a. Then to get r on its own, yes, I'm aware I say r strangely to some people, but this is how we say it in Ireland. Take out the r, so I'm going to factorize r, and it gives me 5m squared minus 1. So this is the tricky bit. I take out the r, I factorize it out, and then I can get r on its own. So r is equal to 6a over 5m squared minus 1, and that is the answer. Okay. Question 13. So we have a frequency table, gives information about the number of mice in some nests. So we have the number of mice and the frequency. So for example, there are 6 mice in 13 nests. There's 7 mice in 16 nests. It says the mean is 7. Work out the value of x. So we don't know how many nests have 8 mice. Okay, so the normal way to get the mean of a frequency table is you multiply all of these out first. So 5 times 4 is 20. 6 times 13 is 78. 7 times 16 is 70 plus 42, which is 112. 8 times x is 8x, and 9 times 6 is 54. So to get the mean, I add all these up. I go 20 plus 78 plus 112 plus 8x plus 54, and I divide by the total frequency. So I add all these up. 4 plus 13, 4 plus 13 plus 16 plus x plus 6, and this, because this would give me the mean, so this divided by this has to equal 7. Okay, now I'm going to add up all these numbers. 20 plus 78 plus 112 plus 54, I'll leave the 8x after, it's 264. So 264 plus 8x all over 4, I can do this in my head, 4 plus 13 is 17, plus 16 is 33, plus 6 is 39. So it's 39 plus x, and this equals 7. There's my equation. Now I need to just solve this equation. 264 plus 8x, multiply across by the denominator. 7 times 39 plus x. 264 plus 8x equals 7 times 39 is, I'm not going to risk making a mistake, guys. 7 times 39 is 273. This is 273 plus 7x, because 7 times x is 7x. Subtract the 7x, 8x minus 7x, and subtract the 264. 273 minus 264 gives me x equals 9. So the answer is x equals 9. Okay. Question 14. Marcus plays 2 games of tennis. For each game, the probability that he wins is 0.35. Complete this, right? So this is an easy 2 marks, guys, because this is 0.35. This has to be 0.65 because they add up to 1. And this is the same because it doesn't change for the second game. So this is 0.65. This is 0.35. This is 0.65. Work out the probability that he wins at least one of the 2 games. So if he's going to win at least one of the 2 games, either, so there's 4 things that can happen. This one, there's there's this, there's this, there's this, and there is this. these are the 4 things that can happen. Of the 4 things, which ones does he win at least 1 game? Well, in this one, he wins at least 1 game. He wins 2 games. In this one, he wins at least 1 game because he wins the first game. In this one, he wins at least 1 game because he wins the second game. And in this one, he wins no games. So this one, no. So what I need to do is add up these 3 probabilities. Or, if you're really smart, work out this probability and subtract it from 1, because that's the probability that he wins no games. But I'll just do it the old school way, guys. It's going to be 0.35 times 0.35. That's the first one. That's the green one. Plus, because it's OR, 0.35 times 0.65. Plus, that's this one, plus 0.65 times 0.35. And this whole thing equals, calculator please, 0.35, I'm just going to do squared, plus 0.35 times 0.65 plus 0.65 times 0.35 gives me 0.577 0.5775. 0.5775. Correct. Okay. Question 15. Trapezium. This is a trapezium. All measurements are shown in centimeters. The area is this. Show that this is equal to this. Right, so guys, it's a trapezium and it says area. Go straight to your formula book. So the formula sheet, I'm going to go up here, guys, and get it. Just so you all remember where it is. Trapezium, there. Let us bring this down. To here. Okay, I'm just going to put that over here, guys, so you can all see it. So the area of a trapezium is a half. Area is equal to a half A plus B. Now the A plus B is the 2 parallel sides. So it's this, it's my A, x plus 5, plus B, which is plus 3x minus 2, times H, which is this. So now, guys, while this looks like a horrible question, because you're like, what is going on? Once you just look at this formula and sub in the stuff, you can maybe see how this can become this. Now this is equal to 133, because it tells you the area equals 133. I'm going to multiply across by this 2 first, guys. So what I'm going to do is, well, actually I'll do these 2 steps in one go if this is okay, guys. I'm going to do x. I'm going to multiply by 2. So instead of 133, it's 266. That's this multiplying by this half here. Multiplying by 2 gets rid of the half. And I'm going to do x plus 3x is 4x, and 5 minus 2 is 3. 2x minus 3. So this times this equals this. But we need to show this. So I have to multiply this out. So 4x times 2x is 8x squared, which is good because that's what I want. 4x times minus 3 is minus 12x. 3 times 2x is plus 6x, and 3 times 3 is minus 9, and this equals 266. Now I'm nearly there, because 8x squared minus 6x, because minus 12 plus 6 is minus 6, and then minus 9 minus 266, because I'm going to subtract this, is 0, and this will give me what I want. Minus 6x minus 275 equals 0. Okay, 3 marks. Then it says, find the value of x, show you're working clearly, right? So x is x is a value here, but I'm just trying to figure out, is it going to be positive or negative? So it has to be positive because it's a length. And if you put, well, it has to be at least a certain value, but it can't be, yeah, it can't be negative, guys, sorry, because if it was a negative value, then this length wouldn't be a negative, or would be negative, which doesn't make any sense. So it has to be positive. Now I know I can get 2 solutions from a quadratic, and I can just write my answer here. But problem here is it says show clearly you're working. So we have to solve this really horrible looking quadratic. What I'm first going to do, guys, is get the answer. Now you will get no marks for what I'm about to do here. I will obviously do it properly in a second, but I just want to show you. I'm going to go to polynomial degree 2, and I'm going to solve it 8, -6, and -275, and it gives me x1 is 25 over 4, so x equals 25 over 4, which is 6.25, or x equals -11 over 2. Now I told you guys x can't be negative. It has to be positive because it has to do with the length. Okay, so that's my answer. Done. Now that obviously isn't good enough. I have to show my working. So I could factorize this. This is one of the worst factorizing questions I've ever seen. So I don't even think I want to try and factorize it. So I'm gonna use the quadratic formula. So the quadratic formula, guys, if you can't factorize it, you can always use the formula. X equals minus b plus or minus square root b squared minus 4ac all over 2a. This is given in the formula booklet. A is 8, b is -6, and c is -275, straight from here. Then I just sum in these numbers. Minus b makes this positive, so it's 6 plus or minus the square root of b squared is -6 squared, so it's 36, minus 4 times a times c minus 275 all over 2a, which is 2 times 8, which is 16. So it's going to be 6 plus the square root. Now I'll write at the side, it must be positive. So it's 6 plus the square root of, I'll do this all in one go, 36, hang on, 36 minus, if you like, 4 times 8 times -275, and that gives me 8836. So it's plus the square root of 8836. Is that what I said? All over 16, which is equal to 6 plus, hopefully this has a square root, guys, 8836, 94. There you go. So it's 6 plus 94 over 16, which equals 100 over 16, which equals 25 over 4, if you simplify it. So there you go, guys. That's the working shown. You might want to put just here to let the examiner know, or you can just write must be positive, because that's why I got rid of this negative, because x has to be positive because it's a length. Okay, question 16. similar shapes. A has a volume of 405, B has a volume of 960. The volume factor, so guys, if you've ever seen any of my scale factor questions, I always do scale factor, area factor, volume factor. So my volume factor is 960 over 405, because this is just this divided by this. That is 960 over 405. Okay, well, actually, I'm going to leave it like that because I quite like that number. It's 64 over 27, and I'll show you why I like the number in a second. That is 64 over 27. That is the volume factor. Now, once I have the volume, I can't go straight from volume factor to area factor. I have to get the scale factor. So the scale factor is the cube root of this. Because if you remember, if you get the scale factor, and let's just say it's whatever, p, let's call it p, then the area factor is p squared and the volume factor is p cubed. So now if I have the volume factor and I want to go back to the scale factor, I need to get the cube root of 64 over 27. Now the cube root of 64 over 27, this is why I said I like that number. It's actually, I'll do it with a calculator to show you, but it's actually 4 over 3, because the cube root of 64 is 4 and the cube root of 27 is 3. 4 times 4 times 4 is 64, 3 times 3 times 3 is 27. But obviously, guys, we're not all able to do that. This is actually the cube root of 64 over 27, which is 4 over 3. So that's the scale factor, but the area factor I then need to say is 4 over 3 squared, which is 16 over 9, because 4 squared is 16, 3 squared is 9. Then, if we're talking about area, like surface area, I care about the area factor. So B has obviously a bigger area than A, so I just need to do 928 divided by the area factor, which is 16 over 9. So this will give me the answer. 928 divided by, I'll write it properly like this, 16 over 9. This gives me 522. So the surface area is 522 centimeters squared. 522. Okay. Question 17. F is the function such that f of x equals this. Work out f of 5. Right, that one, guys, I think is easy. F of 5 is just 4 minus 3 times 5, which is 4 minus 15, which is equal to negative 11. G is the function such that g of x is this. Find the value of x that cannot be included in any domain of g, right? So guys, this is a, if you've never seen this before, this is a strange question, but hopefully you have seen it before. What is the one thing you cannot do? Well, there's a few things you cannot do, but in mathematics, one very, very important thing you cannot do is divide by 0. So you cannot divide by 0. So if the bottom 1 minus 2x equals 0, you've got a problem. You can't do that. It can't be in the domain because you can't divide by 0. So I'm going to define the value of x that I can't do, or that I can't use. I'm going to say, well, what is the value of x when it does equal 0? So I just solve this equation. 2x equals 1, x equals a half. So the answer is a half, or 0.5. C, work out f g of minus 1.5, right? So firstly, guys, I get g of minus 1.5. G of minus 1.5 is 1 over 1 minus 2 times minus 1.5, which is equal to 1 over 1 minus 2 times minus 1.5. Use a calculator if you want, guys. That's going to be 3. 1 plus 3, which is equal to 1 over 4. So I have g of minus 1.5 is 1 over 4. So I just need to get f of 1 over 4, which is 4 minus 3 times 1 over 4. Again, use your calculator if you want. That is equal to 4 minus 3/4 is 3.25. 3.25. Okay. Question 8. P is equal to a over m minus x, right? These questions, guys, often cause problems, but once you understand them, they're not that bad. Well, that's debatable. X is equal to 8, correct to one significant figure, right? I'm going to do what I always do, guys, and I draw out my line. So this is 8, one significant figure, so the next one is 9, and the next one is 7. I then, well, I need the midpoint between this and the midpoint between this. This is 7.5 and this is 8.5. Now I have the upper bound and the lower bound for 8. Next one. This is x. Now I'll do a. A is correct to two significant figures. It's 4.6, 4.6. So the next one up is 4.7. The next one down is 4.5. The middle is 4.65. This guy's middle is 4.55. Now I have the upper bound and the lower bound for A. Finally, M is 20 to the nearest 10. So 20, that means the next one up, because it's to the nearest 10, is 30. And the next one down is 10. The middle of this guy is 25. The middle of this guy is 15. Upper bound and lower bound. So that's the first kind of thing to do, but it's not, we're not done, because we need to find the lower bound of P. So how do I make P small, right? So let me write this down. To make P small, we make, okay, because P is this fraction. If you want P to be small, do you want the numerator to be big or small? Well, you definitely want it to be small, because it's the numerator. If you want to make P small, do you want the denominator to be big or small? Well, you want it to be big. So if the denominator is big, we want M to be big, but because we're subtracting x, that'll actually just make the denominator smaller. We want to subtract a small number, so I'm going to make x small. So this is arguably the hardest bit of the question, to figure out which one you're doing. So A has to be small, M has to be big because we want a big denominator. We want a small numerator and a big denominator, but x has to be small because I'm actually subtracting it from the denominator. So I make it small. Okay, and then we just go lower bound is equal to a small a, so I just look at this guy, 4.55. A big M, which is 25, and a small x, sorry, I did the wrong one. Oh, no, I didn't. A small x, which is 7.5. So just to repeat, a small a, 4.55, a big M, 25, and a small, that's a point, a small x, 7.5. And this, hopefully, gives me the answer, 4.55 over 25 minus 7.5, no, not 7.4, have to do it again. 4.55, 25 minus 7.5, which is equal to 13 over 50, or 0.26, which is correct. 0.26, 0.26. Okay, that is 18. Question 19. The histogram shows information about the numbers of minutes some people waited to be served at a post office. Work out the time. Work out an estimate for the proportion of these people who waited longer than 20 minutes. So it's like the fraction. So basically, guys, I just need to find what fraction of the whole, because if you remember, in a histogram, it's all about area, the number of people. The area gives you the number of people. So I just need to find out what fraction of the total is this blue area here. So what fraction of the total area is the blue area? So the total area I need to do. So guys, this is going up in 1, 2, 3. Sorry, 1, 2, 3, 4, 5. So every 2 small boxes is 1 minute. So I'm gonna say 2 times, so the total area is equal to 2 times 2.5, 2 times 2.5, plus this area is 1, 2, 3 times 4, plus this is 5 times 3.4, 5 times 3.4. So just note, guys, these are going up in point, each small box is 0.1, so that's 3.4. 5 times 2.2. I'll go to the next line here, plus 5 again times 1, plus 10 times 1. And this equals, let's use my calculator, 2 times 2.5 plus 3 times 4 plus 5 times 3.4 plus 5 times 2.2 plus 5 times 1 is 5 plus 10 times 1 is 10, gives me 60. So the total is 60. So there's actually 60 people who waited in the shop. And this area above 20 is equal to, I'll write that in letters, above 20 mins is equal to 10 times 1, which is 10, and we knew that from here. So the proportion is equal to 10 out of the total, which is 60, which is 1 over 6, 1 over 6. Okay. Question 20. A, B, C, D are points on a circle. P, C, Q is a tangent to the circle. AB equals CB, AB equals CB. So that's an important bit of information, guys. These two are the same, which actually gives me the idea to join these straight away without even reading the rest of the question. I'm going to join these because now I have a triangle, and I think that might help us, but we'll get to that in a minute. So he says angle BCQ is x, so this is x. Prove that the angle CDA, this angle here, I need to prove that this angle here is 2x. give reasons for each stage you're working. So I can't say it's 2x now, I have to prove that it's 2x. Okay, so firstly, this is difficult. Secondly, note, this is a tangent, and a few things we can get from the tangent, like the tangent and the radius meet at 90 degrees, but I don't have a radius. What I do have is this triangle here. Now, if you remember, the alternate segment theorem states that this angle here must equal this angle here. So this is x. That's the alternate segment theorem. Check it out. So I'm going to say, because it says give reasons for each stage of your working. So I'm going to say angle CAB equals x degrees. And I'll just put in brackets alternate segment theorem. That's good enough for the reason. Okay, then if this equals x, this has to equal x, because, like I said at the start, this is an isosceles triangle, so these two angles have to be the same. So I'm going to write that down as well. Angle ACB equals x degrees. I'm going to put it in brackets. Isosceles, I hope that's spelled correctly, isosceles triangle. That'll do for my reason. And then I can say this angle here has to be 180 minus 2x, because, so let's write that down, angle CBA equals 180 degrees minus 2x in brackets. Angles in a triangle add up to 180 degrees. The reason I'm saying that is because look, this is x plus x is 2x, so this has to be, I have to subtract these two from 180 to give me this angle, so it has to be 180 minus 2x. Okay, and then finally, these two, this plus this, so angle CDA, which is the one I'm trying to get, plus angle CBA equals 180 degrees, because so this angle plus this angle add up to 180 degrees. Why? Because they are what we call cyclic. It's opposite. Sorry, I should write that. Opposite angles in a cyclic quadrilateral. Cyclic quadrilateral because it's a quadrilateral four-sided shape that's on a circle, so we know opposite angles add up to 180. So now I can say angle CDA, that's the one I'm trying to find, plus CBA, which I know is this, plus 180 minus 2x has to equal 180. Then by kind of solving this equation, angle CDA equals 180 degrees minus 180 plus the 2x, which equals 2x, which is what they wanted us to show. I'm going to write QED, which means I've shown what they wanted. I've shown what they wanted me to show. Done. So obviously, guys, not an easy question. Question 21. The line L has equation this, line M goes through this point and this point. L is perpendicular to M, work out the value of K. Okay, so perpendicular, guys, that tells me I need to find the gradient of a line. So this line, 4y minus 6x equals 33. What's the gradient of this line? To find it, I have to rearrange the equation. I want it in the form y equals mx plus c. So I have 4y equals 6x plus 33. So I add the 6x. And then y equals, I'm going to divide by 4. 6x over 4 plus 33 over 4. So m, the gradient, I'm going to call it m, is equal to 6 over 4 because it's mx plus c. So it's 6 over 4 or 3 over 2 simplified. Which means the perpendicular gradient, I'm going to write it like that, perpendicular gradient. And note, guys, my m is nothing to do with the capital M. It's just it's m for gradient. So the perpendicular gradient, if you know the gradient is 3 over 2, you know the perpendicular gradient is minus 2 over 3. You flip it and change the sign. Okay, so we know the gradient of m, capital M, is minus 2 over 3. So I can then say y2 minus y1 over x2 minus x1. That's the gradient between 2 points. This gradient has to equal minus 2 over 3. Gradient is equal to minus 2 over 3. So I'm going to do x1, y1. Write it here. x1, y1, x2, y2. So y2 is k minus 6 over x2 minus x1 equals minus 2 over 3. And now I can just solve for k. How do I do that? Well, first I'll do minus 4 minus 5 is minus 9 equals minus 2 over 3. I'm going to cross multiply, so I'll multiply by 3 times k minus 6, and do minus 2 times minus 9, which is plus 18. K minus 6 equals 18 divided by 3, which is 6, and then k equals 6 plus 6, which is 12. So I end up with k equals 12, which is not the right answer. So I've made a mistake. What mistake did I make? This was all correct. This is correct. This is correct. y2 minus y1, k minus 6 over this minus this equals minus 2 over 3. This is fine. Yes, guys, I've made look what I've done. A very common mistake that if my students, oh no, sorry, I didn't do that. That was right. 3k minus 6 equals 18. Okay, strange. Maybe I took the answer down wrong. I need to check. Okay. So it was right. I just took down the answer wrong. I actually wrote down the number of marks. Anyway, k is 12. That is correct. Okay, question 22. Okay, warning, guys. This question is hard. The diagram shows a cone. AB is the diameter of the cone. V is the vertex of the cone. Given that the area of the base of the cone to the total surface area of the cone is 3 to 8. Work out the size of angle AVB. Okay, so the first thing I'm going to do is draw a straight line down here. Why? Well, I need it. I need to figure out, because the curved surface area of a cone is pi or L, so I need to find this value L. This is the what do they call it? The slant length of the cone. and I'm going to call the base, the radius of the base, r for radius. This is H, but I don't actually need it. So the area, I'm going to do some of this working up here, guys. The area of the base to the area of the base to the area of the cone. Okay, area of base equals pi r squared. It's a circle. It's a cone, so the area of the base is pi r squared. The area of, or the total area, the total, I'll call it total surface area, TSA, is equal to the base, I have to include the base in the total surface area of a cone, plus the curved surface area. Now the curved surface area is pi or L, where L is the slant length. That is in the formula booklet, guys, that bit, pi or L, but it doesn't include this, so you just have to be careful. You have to do the curved bit plus the circle. Okay, now, because he's mentioned, well, I have to find the angle AVB. That makes me think that I need to find this angle here. Let's call it X. So here I'm going to write look at this triangle. This is a right angle triangle, and I'm trying to find an angle. It's not, X isn't the angle I'm trying to find, but I'm actually trying to find 2X, because it's just double this, because this is half the angle. Anyway, the sine of X is equal to opposite or over slant length, which means that the slant length, the length, is equal to or over sine X. So I've just multiplied by L and divided by sine X in one go. So now I have the length is equal to or sine X. Okay, now this is where it gets tricky. Well, it's already got tricky, but let's do the area of the base. So the area of the base, pi r squared, to the total surface area, which is pi r squared plus pi r L. Now instead of L, I'm going to put or over sine X, because we figured out L is r over sine X. So this to this is equal to 3 to 8. It tells us that. Now the reason I like to see this, that I've now got my L in terms of r, is I've got pi r squared here, I've got pi r squared here, and I've got pi r squared here, which I can cancel. So let's just show you what I mean. Pi r squared to pi r squared plus pi r squared over sine X. That's when I just multiply this by this. This equals 3 to 8. Now I'm going to, I'm just going to come down here a bit. I'm going to divide with ratios, guys. I can divide both sides by the same thing. So I'm going to divide by pi r squared. So this is 1 to 1 plus 1 over sine X. Okay, I've divided this by pi r squared, this by pi r squared, and this by pi r squared, and I've got this. And this is equal to 3 to 8. Now, what I'm going to do is I'm going to multiply both sides by 3. So now I have 3 to 3 plus 3 over sine X. So I multiply this by 3 and I multiply this by 3. And this is equal to 3 to 8. Now the reason I've done that is because if the ratio of 3 to this equals 3 to 8, then this has to equal 8, So 3 plus 3 over sine x equals 8. Now I have 3 over sine x equals 8 minus 3, which is 5. 3 equals 5 sine x multiplied by sine x, and sine x equals 3 over 5 divided by 5, which means x is equal to, I need to do the inverse sine of 3 over 5, which gives me 36.869. 36.869. I just put enough digits there for the moment, which means 2x is equal to this times 2, which is 73.739 or 73.74. Let's go. 73.74. He says 1 decimal place, so 73.7. Obviously, guys, this is a very, very difficult question. Last one. Okay, I think it's the last one. Yes. So, question 23. ABCD is a trapezium. DC is 3AB. Okay, DA is this, DB is that. Find the exact magnitude of BC. Okay, first we will draw this trapezium. So it looks something like this: A, B, C, D. Okay. Now trapezium, guys, just means, hang on, I'll have to draw this one again. A trapezium means that there are two parallel sides. So these two sides here are parallel. That is what a trapezium is by definition. So let's say we have A, B, C, D. DC, that is this guy here, is equal to 3 ABs. Okay, so actually I'm gonna actually redraw this, sorry guys, because AB and DC, they are the, okay, let's redraw that. They are the parallel sides. So I'm gonna actually go AB is here. That's AB. And DC would be, okay, this makes more sense. This is DC. Those are the parallel lines. Okay, A, B, C, D. When it says a shape like that, guys, it has to go in order. It has to go A, B, C, D. But he's saying AB, which is that, is DC is 3 of those. So DC is a lot bigger than that. Okay. DA is minus 2, 3. So this vector here is minus 2, 3. Now, fair enough. You might say, well, negative 2 is going left, but I'm actually not too worried about that for now. Let's just assume it's drawn in a different. You don't have to draw accurately. Okay, so that's minus 2, 3. DB is minus 1, 7. Okay, so this vector here is minus 1, 7. Find the exact magnitude of BC. Okay, to get from B to C, well, I don't know BC, so I'm going to have to probably come down here and along there. But I don't know this value, but I do know it's 3 of these, 3 ABs. So that's the trick. I'm going to find AB. So watch this. I can say DB, that's from here to here, is equal to DA, which goes from D to A, plus AB. That makes sense, because look, to go from D to B, I go dA and AB. There we go. dB we know is minus 1, 7. dA is minus 2, 3. And AB is the thing we don't know. So let's just call it XY. So to find XY, I need to subtract this. So I need to go minus 1, 7 minus this. So it's like solving an equation. I subtract this vector. Minus 2, 3 equals XY. And then minus 1 minus minus 2 is 1. 7 minus 3 is 4. So the vector is 4, and this is the vector AB. So AB, which is XY, is equal to 1, 4. If AB is 1, 4, what is DC? Well, DC, sorry, not 1 over 4, 1, 4. Then DC is 3 of these. So it's going to be 3, 12. I just multiply this by 3. Finally, well, actually, sorry, it's not even finally. And guys, this is the last question of the paper. So it shouldn't be surprising that this is difficult, but it is. To get from B to C, that's what I'm trying to get, the magnitude of BC. So from B to C, I'm going to go BD, BD plus DC. I know BD. It's minus this. So it's 1 minus 7. It's the reverse of this. And DC, I know it's 3, 12. So I add these. 1 plus 3 is 4. Minus 7 plus 12 is 5. So now I have BC is 4, 5. All I need to do is get the magnitude of BC. The magnitude, I'm going to write like this. The magnitude of BC is equal to the square root, if you remember the magnitude formula, of 4 squared plus 5 squared, which is the square root. 16 plus 25 is 41. And then the square root of 41, you can actually leave it like that, guys, if you want. Does it say the exact? Okay, sorry, you have to leave it like that, guys, because he wants the exact form. So just leave it as square root of 41. Okay, obviously, as usual, guys, the last few questions are challenging. That's normal. You have to expect that. But obviously, if you want those high grades, you got to be able to do them. And it always helps with your understanding to try and understand as much of those questions as you can. That's it, guys. That is the paper. I'll see you for the next one.